We have seen that the Earth contains energy within the interior of the planet. But how does that energy get to the surface to heat groundwater? Heat energy always moves in the same direction, from hot to cold. Because the core and the mantle are both hotter than the crust, heat will move outward. But the crust will normally insulate the interior of the planet, trapping heat within. The heat must seek out a passageway to escape the interior of the Earth and move through the crust. Nature has placed a convenient escape: fault lines. Plate tectonics involve three different plate boundaries: divergent, where two plates spread apart; convergent, where two plates move together; and transform boundaries, where two plates slide past each other. Each of these boundaries represent breaks in the crust and offer locations where heat can move towards the surface of the Earth. We live in an interesting location, almost exactly alongside one of the longest plate boundaries in the world, the San Andreas Fault. This fault is more than 700 miles long and is of the transform type. The plate we sit on is known as the Pacific Plate and is moving towards the northwest. The plate to the east, known as the North American Plate, moves towards the southeast, with Yuma and Hopeville along for the ride. The plates move at about the same rate that your fingernails grow, about 1 inch per year or 2.5 centimeters per year. Along this fault, there are areas where the motion is totally transformed, but other areas along the fault actually split apart and look more like a divergent boundary. These features are illustrated in the tectonic table with the "Why Here" part of our exhibit, and are called pull-apart basins. These basins provide areas for the upwelling heat to come closer to the Earth's surface and heat the groundwater to high temperatures. This provides the energy we harness in our geothermal facilities. These pull-apart basins are frequent locations for geothermal power plants and natural geothermal features, such as geysers and mud pots when on our dry land. But these same pull-apart basins also exist beneath the surface of the Gulf of California. To our south, the divergent sections allow hot magma to approach the seafloor, heat the seawater, and eject the hot water along with dissolved minerals into the deep sea bottom, in locations we call black smokers. These regions provide habitats for a variety of very unique sea creatures who depend on the minerals from the black smokers for the basis of their food chain, not sunlight and photosynthesis as most land-based food chains do.